Okay, question 15. A hollow cone with its vertex downwards and its axis vertical revolves about its axis with a constant angular velocity of 4 pi rads per second. A particle of mass m kilograms is placed on the inside rough surface of the cone. The particle remains at rest relative to the cone. The coefficient of friction between the particle and the cone is 1/4. The semi-vertical angle of the cone is 30 degrees and the particle is a distance L from the vertex of the cone. So in part 1 we want to find the maximum value of L, correct to 2 decimal places. So here we're going to show the three forces acting on the mass. The downward force is the weight. The normal reaction R then is perpendicular to the surface of contact. And if we want to find the maximum value of L, this means that the particle is at its highest point in the cone and it's about to slide up the cone. So that means that friction has to point back down the cone. And the coefficient of friction is 1/4. Next of all then we have to resolve the friction and the normal reaction into horizontal and vertical components. So if we split up R into horizontal and vertical components, so if this is R, this angle is 30 degrees, the horizontal component is R cos 30, which is √3 over 2 times R, and the vertical is R sin 30, which is a half R. If we resolve then the friction, the 1/4 R, into horizontal and vertical components, the vertical component then is going to be 1/4 R cos 30, and the horizontal component is 1/4 R sin 30, and that works out as 1/8 R. So because the mass describes a horizontal circle only, it means that vertical forces are equal. So upward forces are going to equal downward forces. So the only upward force is 1/2 of R. Now the two downward forces we have are √3 over 8 times R and mg. If we multiply across by 8, just to get rid of fractions, you get 4R equals √3R plus 8mg. And we're going to try and get R on its own. So if we bring the √3 over and subtract, and then we can factorize out an R, and this means then R on its own is going to equal 8mg over 4 minus √3. Next of all, if we examine the forces acting on the particle towards the center, so the centripetal force Fc is mr omega squared. Now the forces towards the center then, we had a √3 over 2 times R plus 1/8 times R, and this equals mr omega squared. Now we were told that omega was 4 pi. We can also multiply across by 8 again, just to get rid of all of the fractions, and then you get 4 √3R plus R equals 8mr times 4 pi to be squared. Now 4 pi squared is 16 pi squared, so the right hand side then works out as 128 mr pi squared. On the left we're going to try and get R on its own, so we factorize out the R, you get R on 4 √3 plus 1. So this means that R equals 128 mr pi squared all over 4 √3 plus 1. So using equation number 1, we got R on its own, and using equation number 2, we also got R on its own. So we can equate the two right hand sides. And this means then 8mg over 4 minus √3 equals 128 mr pi squared all over 4 √3 plus 1. Now we can cancel the m's on both sides, and 8 divides into 128 to give 16. So we're going to get R on its own. So if we want to leave this R here, the 8 divides into 128 to give 16. The m's cancel. So we're going to bring the 16 pi squared across, and that'll go on the bottom. 4 √3 plus 1, we'll bring that across and multiply. So you're left with 4 √3 plus 1 times g over 16 on 4 minus √3 pi squared equals R. Now using a calculator, if you insert that into your calculator, R works out then as 0.216944. Now however, from this right angle triangle, the sine of theta is the opposite, which is R, over the hypotenuse, which is L. So the sine of 30 equals R over L. This means the sine of 30 then is going to be 0.216944 over L. And then we can swap the L and the sine of 30. So that means L is R over the sine of 30. And then this works out then to 2 decimal place as 0.43 meters.